All right. Hey guys, we're going to do a very quick, simple lesson on special cases of factoring. So by now you guys are pretty good. You should be pretty good at factoring quadratics. So I'm going to show you a couple of patterns and formulas for factoring special cases. One of these special cases you've seen and used and should be pretty familiar with. We'll just take it up a notch in level of difficulty and type of problem. So the first one is this difference of squares. And like I said, we're familiar with that. So in general, the difference of squares, if you're factoring a difference of squares, which is literally something squared minus something else squared. So this is a difference of squares. Both of these numbers are perfect squares, and I'm taking the difference of them. This factors to two binomial factors, so two factors with two terms each, and those two terms are just the a and b value themselves added together, a plus b, and then the subtraction of a minus b. This is something we've seen and can apply really easily over here in these examples. So in problems 1 and 2, this is what you guys are used to seeing with difference of squares. X squared minus some other perfect square, or y squared minus some other perfect square. So we know already that this factors to x plus 2 times x minus 2. And then the second one, example 2, y squared minus 25. So y is being squared, and 5 is being squared. So my two factors are y plus 5, y minus 5. So I'm going to show you a couple more examples here with 3 and 4, where they're not as simple looking as examples 1 and 2. So I see in example 3, it doesn't look like a traditional difference of squares that we're used to seeing. Instead, I have 9x squared. So before I apply the formula, I need to stop and think, what am I squaring to get 9x squared? Because that's going to be the terms that I see in my a and b in my formula. So to get 9x squared, we know we're squaring 4 to get 16. And to get 9x squared, we're actually squaring 3x, not 9x. So that 9 is also a perfect square. So once you've identified that a value, so 3x, and the b 4, then I can apply it. So it would be 3x plus 4 times 3x minus 4. Now let's look at example 4. So this one looks different too. Notice we've got a variable in each, but we can confirm that this is definitely still a difference of squares because I can rewrite this whole thing, 36, as something squared, and I can rewrite 4w squared as something squared as well. So I just need to figure out, again, what that a and b term is. What is the single term that I'm squaring to get 36z squared? That's 6z. And I'm squaring 2w to get 4w squared. So now I can apply that. So 6z plus 2w times 6z minus 2w. So as I said, 3 and 4, this is just an extension of what you guys already know about difference of squares. So there's also a formula for these other cases where we have a difference of cubes. So it's similar in the fact that we're cubing two different things. So x cubed and a cubed. Each of those things are perfect cubes, meaning they are exactly the cube of something else. Unlike difference of squares, there's also a sum of cubes formula. So there is no sum of squares formula, only difference of squares. So we can't factor sum of squares over the real numbers. However, we can factor sum of cubes over the real numbers. So we actually are going to have two formulas. They're very similar to each other. And it's really just about practicing and memorizing and applying the pattern that we're going to see from the formula. So a difference in sum of cubes, we actually start factoring these in the same way, regardless of whether it's a subtraction or sum of cubes. So the formula, the way that these factor, there are two factors that these factor into. The first factor, I guess I'll just write it right here, has two terms only. It's a binomial. The second factor is a trinomial, meaning it has three terms. So I'm just starting by explaining any difference of cubes is going to factor in this way. Two terms and then three terms. And I'm going to explain how each of these terms is found. So in the first one, it's really similar to sum and difference of squares. So we have a squared minus b squared. The factors, a themselves and b itself are the terms in each of these two factors. Same with this first factor here. So whatever x is, whatever is being cubed to get x cubed, which is just x, that is the first term of the binomial. And a itself, not a cubed, but whatever I'm cubing to get a cubed, which is just a. So that's the first and second term here. And I'll get to the signs, the plus or minus, after here in a minute. Now for the trinomial, here's the pattern. The first and last terms are the squares of x and a. So these are both perfect cubes. Remember that. Whatever I'm cubing to get it, those are the first two terms here. Whatever I'm cubing to get a cubed and x cubed, I'm actually going to square those terms for the first and last term of this trinomial. So the first term of the trinomial is x squared, and the last term is a squared. Then in the middle, this middle term of the trinomial is the product of x times a. So that is the pattern no matter what for difference of cubes or sum of cubes. Then it's just a matter of finding out whether or not I have pluses or minuses. And that actually, this is going to sound a little silly, but we use an acronym called SOAP to remember what the signs are going to be. So SOAP stands for same, opposite, always positive. Same, opposite, always positive. So that is referring to the signs in between each of our terms. So right here, I'm factoring a difference of cubes. So that's what the same is. The first operation in our formula is the same as whatever I'm factoring. So since I'm factoring a difference of cubes, my first term is going to be a difference. So same. Opposite is the opposite of whatever I just put down. So if I'm doing a difference of cubes, same is the same. The next one is opposite of that. So this is going to be plus. And the third one, the third operation is always addition. So that is the formula for factoring difference of cubes. Sum of cubes, like I said, it's going to start in the exact same way. The pattern is identical. I'm going to have a binomial times a trinomial. Whatever I'm cubing to get x cubed, so that's going to be x itself and b itself. Those are my two values that are going to be in my binomial. Then the first and last terms of my trinomial are the squares of these two things. So a squared in the front, b squared at the end. In the middle term is the product of a times b. And lastly, I just need to, whoops. I'm sorry, I've been using A's even though I've been looking at the letter X this whole time. If you put X in, that's fine. You don't have to erase it. I guess I could have just changed that to an A. Okay, so X, B, X times B. Okay, and then I go back to the SOAP acronym. So my first operation is the same as whatever I'm factoring, so that's going to be addition. The second one is opposite, and the last one is always positive. So that's it. It's just a matter of memorizing and practicing this formula. So I'm going to walk through just these two with you, and then I'm going to end the video, and I want you to complete these 4 before submitting. So I'm going to do these 2 with you, and then see how you do on the rest. Okay, so I've got x cubed minus 1. So the fact that I only have 2 terms here and I'm asked to factor, I should be thinking of, okay, that's either a difference of squares or a sum or difference of cubes. It's obviously a difference of cubes because I'm cubing x, and 1 is a perfect cube because 1 cubed is 1. So I'm going to apply the formula. So I'm going to set it up. I always set it up with my binomial and trinomial, and then I'm following the pattern. My first and second term in my binomial are the values that are being cubed themselves, so x and 1. Then on the first and last terms of my trinomial are the squares of these two things, so x squared and 1 squared, which is just 1. Then I have my middle term here, which is the product of x times 1, so that's just x. So already it's that simple. I'm almost finished factoring. Then I apply the SOAP acronym. So I was factoring a difference of cubes. So that's going to be the same as that, which is subtraction. O for opposite, always positive. That's it. I have factored this difference of cubes. Not too bad. Now let's do this one together. So this is a sum of cubes. The hint obviously is that I see a 3 here, but then we need to stop and think. 27 is also a perfect cube, and so is 8. So now we need to think, what are we cubing to get 27x cubed? And what are we cubing to get 8? So we need to figure out what is basically the root of each of those, the cube root of each of those things. So I would have to cube 3x to get 27x cubed, and I would have to cube 2 to get 8. So this is my A and B, or my X and B like we had up here. Okay, so we apply the formula. Again, the setup, I'm going to make room for my binomial factor and the trinomial factor. The 2 terms in my binomial are the 2 things that were being cubed to get these 2 values in my original problem. So that is 3x and 2. And this is where I see more mistakes right here, because I'm squaring. We know, again, that this first and last term are going to be the squares of 3x and 2. 3x squared. That's not just 3x squared. Remember, I'm squaring this whole thing. So 3x times 3x, which is 9x squared. My last term is 2 squared, which is 4. And then my middle term is the product of 3x times 2, which is 6x. Those are all my terms. Now I just need to fill in the operations. We started with addition, so same, opposite, always positive. That's it. So now you have your formula for sum or difference of cubes. We've got 2 formulas, very similar. I want you to try these 3 on your own and then submit to Schoology. Very simple, sum and difference of cubes, and then this difference of squares. Okie doke, that's all. I will see you guys soon.